So today we're going to talk about conditional probability. And conditional probability, it's kind of in the name, is just the probability of something happening given a prior condition. And we're used to having prior conditions in real life all the time, but we don't necessarily think about them from a probability perspective. So like, for example, if your parents have ever told you, you can go hang out with your friend if you clean your room, or if you do the dishes, or do this, or do that. There's this condition set that kind of dictates whether or not something can happen. So with that, we're going to be looking at examples today that find the probability of something happening given that this has already occurred. So the first example I want to look at here, we've got a Venn diagram here that shows the number of students in a class who study Italian and French. And we're looking to try and find the probability that a randomly selected student studies French. So the condition that we're given here is that they study French. That's what we're given. Also studies Italian. So when we're looking at this, we're trying to figure out, okay, well, first off, how many total people speak French in this class, according to this Venn diagram? And so what we've got to look at the entirety of people that speak French. So the condition is what always determines your denominator. So here, the total people so we're given they speak French. We're only dealing with French speakers now. The condition is going to determine your denominator. And we want to know, out of those people, how many can speak Italian. So the way that we can read this Venn diagram, out of those 15 people, there are 7 who exclusively speak French, and there are 8 that speak both Italian and French. So we're interested in those 8, and that would be the amount of people that, given that you speak French, that you can speak Italian. Now, some notation for you all for this is when we got events A and B, when you see A, I guess we'll call this a straight line or a dash, A dash B. The way that you read this is A given B. So it's like the way that you would read this is the probability of A given B has already happened. So like if you were going to write a notation for up here, it would be, tell me the probability that someone speaks Italian given that they speak French. So the second one is always that condition. So we're going to look at a couple of examples here of conditional probability to start. And the formula for that is you're just going to take the number of occurrences of A and B, the intersection, or the and you're going to divide that by the denominator. The condition always sets your denominator there. And so let's see here. We're going to be doing example 21, which is on page 270. So if you're following along in the book, that's the page number there. And what we're given here is in a town, 25% of residents own a cat, 55% own a dog, and 30% do not own either animal. And the first thing it wants us to do is to construct a Venn diagram for this situation. And so that's what I'm going to do. And we're going to run into a little bit of a problem here, but that's okay. So this is our universal one. So what we can label with here, we know that there are 0.3 of people who have no pets. But the thing is, they tell us that the amount of people who own a dog is, so this entire Venn diagram circle is 55%. We can't just go ahead and put 0.55 in this box right here, because 0.55 represents some of the intersection here. And similarly, and you're probably like, Mr. Price, why are you putting that there? Hang in there with me. Same thing for a cat. We can't just say 25% is the only thing that's going to go in that spot right there. So what we've got to do, we don't know how many people have both a cat and a dog. So what we're gonna have to do a little bit of algebra here. So we're gonna put an X right here. We don't know how many people have that, and we're gonna have to set up a little bit of an equation here, because this X is going to subtract whatever the middle ground is here, 0.55. The intersection is going to have to be subtracted from both of these. So we're going to have to call this particular circle 55% minus that X. And the same thing for 0.25. We're going to have to call it 0.25 minus X. And then we're going to have to do a little bit of math to set that up, because we know if we add all of these things up right here, that they should add up to 70%. So I'm going to write an equation real quick. 0.25 minus X. We're going to add that plus X, and then we're going to say plus 0.55 minus X, and that's going to be equal to 0.7, because we know that 30% of people do not have pets, 70% of people do. So I'm going to combine my like terms here. So my like terms I see are this 0.25 and this 0.55. We can combine all of these X's here. So that's going to give me 25 plus 55 is 80. So 0.80. There's going to be minus 2X plus X. So 0.80 minus X equals 0.7. And from there we can determine that. So 0.8 minus what gives us 0.7. That means that X is going to be equal to 0.1, which now we can fill in that Venn diagram. So I am a little pressed on room here, so I'm going to go ahead and just fill in these values for X. So 0.25 minus 0.1 would be 0.15. 0.55 minus X would be 0.45. And I'm just going to actually write those values here. Sorry, I did not give myself nearly enough room here. So the intersection here is 0.1, and then 0.55 minus 0.1 is 0.45. So these are the values that we're going to use going forward. These are the values for that Venn diagram. So what we're trying to calculate now are these two different probability scenarios. So we're trying to figure out, okay, we'll find the probability that somebody owns a cat given that they own a dog. So remember, the condition that we're given determines the denominator. So what we're really trying to find, probability of having a cat given that they have a dog, that's going to be equal to probability of having a cat and a dog divided by the probability, or the probability that someone has a dog. So what that looks like here, the amount of people that have a cat and a dog is going to be the intersection point there. And what that looks like is cat and dog is 0.1 divided by the people who have dogs. The entirety of dog owners, you have to add those together, is 0.55. And we can do a little calculating to figure out what that is. That is 0.182. So give me 1 second, you all. Sorry about this, you all. My phone is about to die. I've got to make sure I plug it in. Alrighty. We are good to go. Sorry about that. So then the second part here, the probability that someone doesn't own a dog given that they own a cat. So what we have to do is say, okay, we're looking for probability of not owning a dog, D prime here, given that they have a cat. And we're going to set that up, D prime and C, so not having a dog and having a cat, divided by the probability that they have a cat here. So the amount of people that do not own a dog and have a cat, so they exclusively only have a cat, we're talking about this part of our Venn diagram here. So that would be 0.15 divided by the probability that somebody has a cat. So we have to take what percentage of cat owners. The entirety of this cat circle right here is 0.25. And so now we've got to go in and calculate that probability. You can just use a calculator to do so. It is 0.6 or 60%. And so we're going to look at another example here. This one isn't a regular example per se. It's just number 8 from that problem set on page 271. Because I wanted to give you all a choice or a chance, to see 2 examples of a table here. So what we're going to do is determine the probability. I should read the problem first. So urn A contains 2 red and 3 blue marbles. Urn B contains 4 red and 1 blue marbles. Peter selects an urn by tossing a coin. And we want to, in the context of this problem, determine the probability that the marble is red. And so for that problem, what we want to go ahead and try to do is we can set up a diagram, or we can think about the probabilities here. So our chances for picking a red marble here, we could pick a marble from urn A, or we could pick an urn from a marble from urn B. So since there are red ones in both, we have to calculate that probability here. So to do that, we're going to say, okay, for urn A, let's say urn A red. We want to calculate the probability there for it. For urn A, for us to pick it, we have to flip a coin first. So there is a 50% chance, there is a 1/2 chance that we pick it. And then from there, we have to say, okay, well, we're going to multiply that by how many reds are in urn A. So there is a 2 out of 5 chance that we get one correctly from, or a red marble from urn A. So we're going to add that to the probability of choosing one from urn B. So the odds of getting an urn B that is red, we're going to say, all right, well, what are the odds that I have to choose from urn B? That's going to be 1/2. Let's see here. From urn B, there's 4 red and 1 blue. So we're going to multiply that by 4 out of 5. And then we're going to add these 2 things together. So that's going to give me 2 out of 10 plus 4 out of 10. If I add those together, that's going to give me 6 out of 10, which is going to give me 3/5. All right, so the next thing that we're going to look at is, given that the marble is red, what is the probability it came from urn B? So we're dealing with red marbles here. So this is conditional probability. It says, given that this thing is red. So the probability of it being red, given that it came from B. So we're going to have to first figure out how many marbles meet both of those conditions, that are red and in earned B here. And that is a total of, there are 4 reds in there. So we're going to say 4. And then the probability of it just being red in general, that establishes the number of reds, establishes our denominator. So we've got 4 out of 2 reds and 4 reds, 6 reds total. So that's going to give us a 2/3 chance, if we know that the marble is red, that it came from earned B.